Hello everybody, in this tutorial I'm going to show you how I made this rubber joint. So if you look on the screen, you see when I go up here, it's kind of animate. And you can see down on the lower screen how they look. And I'm going to show you how I made them. And I have another scene where I'm going to work in. And let's see, we're going to do load scene here and remove these ones. So I have them here. So if I press play, and this one is actually chain IK, which means this one has the animation rigging component, and on this one I used, as I said, chain IK constraint, and it has a target, and it's kind of following around like this, right? So that's one way you could use it, and also add the other one here and actually use the twist constraint. And twist constraint has, let's see, it has a root target. So that means I can rotate the bottom part. So I actually put it on bone 1 instead of bone 0. And then you have the tip target, and that could be if you want to turn around. This is mostly used in skeletons, if you want it for the spine, you know. So, and what's good about this one, if you notice, is that when I rotate here, you can't do more than 180 degree, but that's fine because in a spine you can't really do that. You see it kind of twists really nice as well. So that's a nice animation component to use. And unfortunately, this one never do that kind of stuff. You see, it always have this straight one. But yeah, that makes sense, I guess. Well, we're not going to be in Unity at all in this tutorial. So let's get started and jump into Houdini. And I have Houdini here, and I'm actually gonna show you what we're gonna do. So we're gonna have a spline here. Well, actually this is a line, so this defines the length of it. And then here we're doing the rubber part. And here we do the metal part, and then we merge it in here. And then here, this part is the skeleton part, where we do the skeleton. And then we kind of do this bone capture by harmonic. And then we have skinned mesh, and then we can just work with it like this. So this is what we're going to do. And then we're going to export it to Unity, of course. So let's get started with this. And we have an empty scene. And the first thing, I'm going to save it. And I'm going to save it here. And I do it next to my scene, which means I have it saved here. So when we work in this folder here later on, we have everything set up. And I'm going to just remove them at the moment. So the first thing we want is a line. Actually, we are in the object root here, so we need a geometry node first. And I'm going to make a line here. Line, perfect. And this line is going to define the kind of overall length and everything of it. So I'm going to have it 3 units. And also, you notice I do it in the Z direction, because Z direction is forward. And when you work with things like rigging and stuff, you want it to be always kind of pointing forward as much as you can. What I mean by that is that the bones should point, the bones local transform should be in the I direction. So that's why I model in the Z direction here. And so if this is going to be the rubber part, and then we're going to have a spear. So I'm going to have this one here, and I'm actually, yeah, this is going to be fine. I'm going to go with this one. So if we take this one here, this line, and then if we just do a resample, now we tick here to see the points. Now we can kind of decide the rubber waves resolution eventually. So put this one into a sweep, and it gives an error because it wants something in the second input, but we're going to make a round tube instead. So here we have it, and you could actually work here with it and make some shape. But the problem here is that you just do the maybe this value here that you do high is actually over here. So we are giving the thickness between two different points. So we're not going to use this scale along curve like this. Instead, we're going to use, we're going to make a wrangler here. And this wrangler, here in the points, we can actually define the shapes. So I'm just going to set this one to set shape like this. And in here, I'm going to have a float min. This is going to be the minimum shape. And we're going to have a max as well. And with these ones, now if we do like this, so at pt num, that's kind of the index of the points. So you see here, if you look here, you see here, it's so tiny number, but it actually says 8 here. And it starts from, 0 over here. So in this one, at pt num, picking up the number. So what we could do, if we do like this, if at pt num and is kind of modulo, I think it's modulo, isn't it? It's this percentage sign. And if we use that one with 2, that means we take all the even numbers and we do something with it. So in this case, we're going to do p scale is equal to min. And if not, then we're going to have this other condition that is p scale is equal to max. And by doing it like this, now we see p scale 0, 0, 0. We need to promote them and give some value. Now we see it's 0 got 1 and 1 got 0. So this is how you can define it. And also if you cogwheel, edit parameters here, you see here you have min and max, and I'm actually going to just make sure you can have up to value 4 on these ones. So we can slide even more. So now if we go into sweep mode, now we see that we have this shape going like this. Super nice. And then in the sweep, in the UVs and attributes, so if we do space 5 here, now you see the UVs, there are no ones, but we do compute UVs, and it's actually doing it all the way from 0 to 1, and then it kind of extrude as long as the curve or a line. Almost. It's actually normalized this one here. So if you want it to be exactly the this kind of just normalize it. If you have like 2.2, I think it goes down to 2, and now actually it made from 3 to 2. But we're going to leave it like this. So now it's actually 3 units long and 1 unit width. So that's great. And now here we have it. And down here we just do a subdivide. So if we remove these ones here, and now you can see we can go back to the set shape and kind of do minimum a little bit more and maximum a little bit more. And maybe we should do this subdivide 2 times, 2 times. Yeah, 2 times is fine. So here you see, and now you see we have a good start and we have an end that's not really that cool. That's because here we do the modular operator. So because we need one more point actually. So if we do this as 14, now we have them both. So yeah, this is how it is. Pretty cool, huh? So if we look in the actually here in the Unity reference, you see that this shape has a little bit beveled edge, and we don't have that one. Let's see, where are we? We are in this one. It's kind of a hard edge here. And so what we need to do, we need to kind of bevel or extrude it and then bevel kind of. So you could, well, we need to do like this. If we do a group and we use on the edges like this, and we remove base group and then include by edges. And here we can actually use, if we do unshared edges. So unshared or shared edges is that you see, if we do, let's do, yeah, well, what I'm trying to explain is that if we do it, this line here is an unshared edge because it's only have one edge. And you might think this is one edge too, but it's actually two because you have one primitive here and one primitive here. And because the vertices goes like this, right? And here too. Then this edge here is actually two edges, which mean it's a shared. But if we do this unshared edges, now we only gonna work with them. So if we do like this, here we only have the unshared edges, so we got these edges. Perfect. Then we just do poly extrude, and I'm actually going to do this group name to extrude up here in the group name. So here I just do group, I have extrude, and here you have it. So this is really good. And we just want to change a little bit here. So if we do point normal and then we do negative here, we kind of get it inwards. And the last thing we do, we just do a bevel on this one, point bevel. And we have the extruded edge, right? Because it's this one here, because we saved it before. And then here we just do a bevel to make it really smooth and nice. So, and we could solve this too, but that's fine. We won't really notice it. It's so, if you look here, we don't really notice it, right? Because it's actually exactly the same setup. So this is the rubber part, and the last thing we're gonna do, I'm gonna do a measure curvature because I'm gonna use this information later. So I'm only gonna do the red channel. So convexity attribute is red, and I'm gonna remove the green one. So we only have this to work with, and I'm going to do a wrangler, and in here I'm going to do b at cd is equal f at red. So this means I convert a float value to a vector color. So we set the color, and we're going to use this in the when we do the material. And actually, I'm going to do a little bit more resolution like this. And then I'm going to do a smooth because I want the red value to be a little bit more blurred. So you see, I put CD in the attribute, and now I can kind of blur it. So I kind of want something similar to ambient occlusion on this one. The last thing I'm going to do here is, before I close this tutorial, I'm going to do set material, and I'm going to do material name is equal to so when we export it in an FBX manner, if you do string and you use FBX material name like this, and this is going to be the rubber, then we will have the FBX picking up this as its own material. So set material, because we're going to have two materials on the same mesh. So that's how we do it. And then I'm just going to do attribute delete here, and I'm just going to remove some attributes that we don't need. So on the point we have concavity, we have red, and that's all. So I'm going to close up the tutorial here and continue in the next one. So thank you so much for watching.